half-life refers to how fast the reaction occurs, but that doesn't tell us whether the reaction actually occurs. So the uncoiling of DNA is favored by entropy. It's not favored by enthalpy. So if delta G is less than 0, that means that the reaction is spontaneous. So can we say based on what we said about enthalpy and entropy whether this reaction is spontaneous at 37 degrees? So in other words, there's a balance. There's two factors which determines whether the reaction occurs spontaneously, delta H and delta S. So if the reaction was favored by both delta S and delta H, we know the reaction is going to be spontaneous. But in this case, it's favored by entropy but not favored by enthalpy, so we're not quite sure what the sign of delta G is going to be. So to answer your question D, you can't tell. Okay, so if we had some numerical values, then we can figure it out. Okay, then for part E, draw a reaction energy diagram for the uncoiling of DNA. So what would that reaction energy diagram look like? So in the reaction energy diagram, what quantity is plotted on the x-axis and what's plotted on the y-axis? Should I put a box here so you can fill in the box? You told me the other day it's easier when there's blanks to fill in. So now all you do is fill in the blanks.
We got energy on the left.
Energy on the x-axis?
Y-axis.
Okay, so yes, we have energy on the y-axis. And what's on the x-axis?
Reaction.
Yeah, reaction coordinate or a progress reaction. Okay, so I'll put both reaction coordinate or the progress of reaction. Okay, so how do you think this reaction looks? Now you said that this reaction, delta H is greater than 0. So if this line represents uncoiled DNA, sorry, coiled DNA, is the uncoiled DNA going to be higher or lower in energy?
Lower.
Okay, so you said that delta H is greater than 0, so that means the DNA uncoiled is going to be higher or lower in energy?
Uncoiled will be lower.
Uncoiled is going to be
Lower.
Lower? So you're saying that this reaction is exothermic?
Yes.
Because didn't you say that you need to break these hydrogen bonds, which means that delta H is greater than 0? Yeah, so if delta H is greater than 0, that means that the energy of the products is going to be higher or lower than the energy of the reactants. It should be higher. Okay, so this is endothermic. So DNA uncoiled. So note that in this case, this energy difference, delta H is greater than 0, which means that we have an endothermic reaction. Now, in this first sentence, it says the uncoiling of DNA has an activation energy of 430 kilojoules per mole. So how do we represent the activation energy in our reaction energy diagram? So we want to show Shahan called it a speed bump. Is it going to be a big speed bump or a small speed bump? Yeah, it's going to be big. So 430, that's a big number. Yeah, so this is going to be our activation energy. So what's that saying? A picture is worth 1,000 words. So you just draw that picture, and maybe I should just left it with the picture last week, and I wouldn't have had to say those thousands of words. Right.
So if delta G is less than 0, it's spontaneous?
Yeah.
All right.
Yeah, so we'll talk more about that later on this semester when we get to the part on thermodynamics. We'll cover thermodynamics in about 2 or 3 weeks. No, we'll cover that sometime later this semester. Okay, let's go on to the next slide. So today in lab, you're going to do the second part of that iodine clock reaction. And in that second part, you're going to measure the activation energy of that reaction. So to measure the activation energy, you can do that by measuring the rate and calculating the rate constant at different temperatures. Now, note that the Arrhenius equation relates the rate constant K to temperature. Note that in this equation, activation energy is also in there. So let's do the following. Let's take the natural log of both sides of the equation. So we have the natural log of K equals the natural log of A minus EA over RT. Let's say you do an experiment. You measure the rate, you calculate K at different temperatures. Then you want to graph your data. So what would you plot on the x-axis and what would you plot on the y-axis based on this equation here? So would you plot K versus T, the natural log of K versus T, the natural log of K versus 1 over T, or EA versus K? Okay, so you want to look at this equation here, and then based on this equation, how would you graph your data? Now, when you graph your data, you want to get you want to be able to draw a straight line through the data points. Okay, so what's that? What would you graph here? So do you want to just give it a go right now, and then we'll see what kind of answer we get. So who says A, K versus T? Who says B, natural log of K versus T? Who says it's C, natural log of K versus 1 over T? Who says it's D, EA versus K? I don't like to put E in, but who's doesn't know or not sure at this point?
C.
Okay, so that means let's spend a minute or two thinking about what the answer is, since only a few of you have an answer so far. Okay, so what are you going to graph in this case? And then what's the slope of that line going to represent? Okay, so I'll give you another hint. Okay, so let's see, we have the natural log of K. Okay, so remember when you're drawing when you're drawing a straight line through a graph, what's the formula of y equals
mx plus b?
Yeah, mx plus b. Where m is the slope and b is the y-intercept. So based on this equation, should we plot on the y-axis natural log of k? And then on the x-axis, x is a, and then the slope is the natural log. And then the intercept is EA over RT. So does that mean what it plot?
Is that negative sign or minus sign?
Where?
The ln a minus, or is it negative?
Yeah, LA minus EA over RT. Okay, because that's from here, Jose. So you have, in this equation, you have K equals A times E to the minus E over RT. So that's why you carry that minus sign down here. And you take the natural log of both sides. Well, you know what? Let's not spend too much time on this because this is chemistry, not math. So although math is a very valuable tool, I don't want to say anything bad about math. Although math is a very valuable tool, we don't want to spend too much time doing math in chemistry. Although we do a lot of calculations and our observations are often quantified by numbers, but we don't still want to spend that much time doing that work. So if we rearrange this equation this way, we have natural log of K equals minus EA over R. Okay, so based on this, can you figure out, is it going to be A, B, C, or D for what we're plotting? Yes, we're going to plot natural log of K versus 1 over T. So note that we're going to plot natural log of K on the y-axis, 1 over T on the x-axis. The slope is going to equal, so the slope is minus EA over R, and the y-intercept is equal to the natural log of A. Okay, so that's what you'll be plotting. So based on that graph, you can measure the slope, and that slope is going to equal minus EA over R. Then you can solve for EA. So that's how you calculate the activation energy of this reaction. Okay, so you do that today in lab. You measure the activation energy, and then in the second part of